Thank you very much for coming. My name is Eric Zelo. I'm the chair of the Department of History and Philosophy, and also the chair of the committee that is organizing the Connections lecture series, of which this is the first event. A few years ago, we had a series called Core Connections, and in many ways, this is a kind of revival of that, but with a slightly different mission. So the Connections lecture series, which I hope will continue for many moons to come, works at showcasing interdisciplinary scholarship and interdisciplinary ways of thinking about challenges in the natural world and in the course of human affairs. Generally speaking, the world does not work in easy disciplinary boundaries. The questions that we need to ask, the problems that we face, involve a lot of interconnections and a lot of challenges that require different approaches. And so this is really a series about that. And I think climate change is one of those topics that definitely winds up crossing a lot of boundaries very quickly. There's a lot of natural sciences there. There's a lot of questions in terms of social sciences and politics and sociology and anthropology. There's a lot of questions in terms of the way that the humanities look at things as well. And so the committee decided, as we were thinking about what we wanted to do for our first series of events, to look at climate change from a variety of vantage points. And so we have three different things happening today that I hope that you'll take part in. Obviously, you're here for the first one, and I'll introduce our speaker in just a moment. At 4 o'clock in this room, free food. We'll just sort of mill around and chat. We've got the good food, the bacon-wrapped scallops, the single best thing that Sodexo does. And that's what they are beautiful thing, beautiful thing. And then at 5:30 in Alphon 205, our second speaker of the day, Cameron Wake, will be talking about the science and the politics of climate change and things that we might be able to do here in New England. His focus is really on New England. All right, but our first speaker, and I learned this on Twitter yesterday, his nickname is Captain Weather. So that's a pretty good nickname. We'll have Dr. Climate and Captain Weather today. So it's like a superhero matchup, which is pretty great. James Fleming is Charles A. Dana Professor of Science, Technology, and Society at Colby College. He has been a research associate at the Smithsonian Institute, holds degrees in astronomy, atmospheric science, and history. His books include the Meteorology in America, 1800 to 1870, from Johns Hopkins Press, Historical Perspectives on Climate Change from Oxford University Press, The Calendar Effect from AMS, Fixing the Sky, which will be the topic of his discussion today, from Columbia, and Inventing Atmospheric Science, published by MIT just last year. He's been a fellow at the American Association for the Advancement of Science, the American Meteorological Society. He's testified before Congress, consulted with the General Accountability Office, served on panels. This is a fairly substantial CV here, I think you'll agree, and served on panels at the National Academies of Sciences. We had a wonderful discussion earlier today with an environmental sociology class that was wide-ranging and covered not only history, but a lot of Jim's other expertise as well in terms of policy and advocacy. So he's interested and able to speak on that as well. Please join me in welcoming James Fleming.
Thank you very much. I'm so happy to be here. I'm happy to be on this side of the Saco River because I went down the wrong side this morning and it was a little bit late. But no, Eric's been a great host and looking forward to the day here. It is lunchtime, so I'll try to keep this a little bit more entertaining than not, I hope. And none of it will be on the final exam, I don't think. So I'm here because of an airplane crash, and used to be a research meteorologist. Used to fly in clouds. I used to write little computer code to model clouds, and then we almost crashed. We clipped off some pine trees landing at a regional airport, and I was in charge of the particle collector, which collected the pine tree. We didn't crash, but we almost did, and I said, gee, I need a new mode of engagement with the atmosphere, and I think that'll be history. So this is a history of intervention. I just got off of a National Academy panel called Climate Intervention. You can get the free PDF from the National Academy, 2 volumes. One is on modifying the albedo or changing the insulation coming into the Earth. And the second volume is on carbon capture and safe storage, not just capturing it. And I'll waive 2 books. This book was 2010. If it's not in your college library, it'll be there by the end of the day. It's called Fixing the Sky, The Checkered History of Weather and Climate Control. And that's based on this. And I'll get to the Academy report near the end when I start to talk a little bit more about policy. And then, as Eric said, I just finished Inventing Atmospheric Science, which is from 1900 to 1960. And I dropped the story off just when Ed Lorenz develops the chaos theory, and we finally have a weather satellite flying. And it kind of goes from Marconi to weather satellites, and from early attempts to make a meteorological time machine to look into the future, to the point where we said, wow, there is really a limit to our provision and how far we can see into the future. So again, if it's not in your college library, it will be, as thank you for inviting me here. Fixing the Sky. When I moved to Maine, it was this was the New York Times that day. It was 1988, and I got a copy of it, and we had the rental truck, and we're moving up from Washington. And I remember quipping to my spouse, I said, it looks like we're headed in the right direction, because Jim Hansen just said global warming has begun. And that's the beginning, 1988, of a vast expansion of the literature, from journalists, from scientists, from pundits, from sociologists, from economists. And so the literature just exploded. Hansen has nuanced the statement since, but this was the cover of the New York Times on the greenhouse effect, about July 1st, 1988. My assumption is to get involved in climate intervention in a heavy-handed way, or to think about fixing the Earth through an engineering scheme. You really have to be motivated. And one of the motivations is fear that the treaties aren't going to work, that individual virtue and mitigation and changing light bulbs is not going to work. And so that a lot of engineer types have thought about, let's make an artificial volcano, or let's make the oceans absorb more carbon, or let's put a whole bunch of water pumps on the polar ice cap, maybe 1 million of them, and have them make more polar ice. And so engineering projects are rising, especially since 2006, when Paul Crutzen wrote his editorial about a policy contribution to climate change. His contribution was, let's use naval guns and shoot sulfates into the stratosphere in the tropics. And so if you think that's a good idea, just hang in there, like buckle your seatbelt. Then we have my friend Bridget Schneider, works at Potsdam with the IPCC. She works on the color diagrams, and what happened was the Intergovernmental Panel on Climate Change always published their reports with Cambridge University Press, and they came out a year later, and they were great big thick things with color separation. And then our world passed what I call the PDF horizon. It was somewhere about 1992, 93, but more and more since then. So all of our information comes now pretty much free and pretty much in color. And so climate change is a very colorful field. And the iconic blue marble, which was developed in 1972 as a NASA image from the Earth, is then contrasted with the burning world images, the angry red planet of projected climate change. And this is another way that climate change is mostly, think about this, climate change is mostly in color, and it's mostly in deeper and darker reds. And red is the bullfighter's color, and red is an angry color, and Earth has turned into an angry red planet based on the climate models. So that's another motivating factor, is this move from our blue and white home in space to maybe an uninhabitable place that needs serious fixing, or it needs metaphors are flourishing, like we're the Titanic and we need the lifeboats kind of metaphors. So this is just like a warm-up to show that you have to be a very concerned environmentalist and think that engineering's the answer before you really can jump into this. And you get the Time magazine cover to be worried be very worried. I think there's some be afraid, be very afraid tropes out there too. And then kind of what I call, this is for my journal, I call it strong misreadings, a journal of strong misreadings. Stop climate change before it changes you. And this is a strong misreading of how fast climate change would affect the evolutionary strains. You're not going to turn into a fish person or the creature from the Saco Lagoon or something. But the people are desperately, we've been in a lot of meetings about how do you picture climate change, and one way is you photograph polar bears on shrinking ice floes, or you make up some sort of an image because you can't see the climate. Astronomer can see a supernova, they look in a telescope, they can sit on an observatory hill for the evening, but a climatologist has to gather data and have different bully pulpits. Usually meteorologists had other people taking measurements in networks. And so maintaining the networks for long periods, seeing instruments changing over the network period, these are very important kind of sociological problems, is how do you maintain standards. And then if you get a bully computer model or a special satellite, you can begin to make authoritative statements. That's a whole other talk, but it's really not related to that picture. But I thought the fish picture was kind of cute, so I put it in there. We do have climate physicians. I think Dr. Climate's here with us today. And this comes from the Intergovernmental Panel on Climate Change. It was published in Nature magazine. And it's an image I published in a paper I called Climate Physicians and Surgeons. And this is the metaphor that the Earth is sick and we need to heal it. They use the blue marble venue, which is sort of Madagascar, Africa. All the ills of the world come in this picture this way semiotically, and then the three white males with their ties on and their thermometers are checking the temperature of the planet, and they're diagnosing and then prescribing probably a low carbon diet for the planet. This comes out of cartooning based on the Nature magazine's coverage of the IPCC. And so the metaphor of the reality of fear, and then the metaphors are flying on how do we fix or stop climate change or heal a broken planet. And then there's this new, I just found this one the other day, I couldn't resist. Just say ah, and the climate physician will diagnose the Earth. This is also semiotically in the southern hemisphere, so the ills are, the orifice there is to be healed is through the south. This one was in the south, the thermometers going in south of Madagascar. And the white Western males, one guy's from Argentina, but they're gonna fix it through the IPCC. And so climate semiotics, I mean, maybe it's something you hadn't thought about, but the people I work with deal with images as well as meanings, as well as the whole panoply of humanistic interpretive approaches to climate. There's the one on planetary surgery. Does the planet need a surgeon? And where would you slice? Who would see? I never had LASIK eye surgery, but I had some operations that now I don't need glasses to read, and so it's really kind of neat. But I signed the form, and I said, if you ruin my eyes, it's okay. I mean, he had to sign the medical release form. But who would sign that form for the planet? Who has the authority to say, you go ahead and do the surgery? I know that we're terminally ill. Let's take out the sunlight. Let's block some sunbeams. Let's turn the oceans into a soupy green source for carbon uptake. You know, that kind of discourse. When you take it to the planetary level, you really get into some certain problems that I'll show you later. Now at MIT we had an all-day meeting. The morning belonged to the Can We Do It group. They were making up ideas. I know what we could do. We could do this, and we could use this leverage, and we could make the planet do that. And the afternoon was Should We Try? And that was the group I was in. And I did a takeoff on this was the logo from the meeting. Sort of a male hand, like godlike in scale, was reaching up to nowhere to turn the thermostat. And the implication is that there is a planetary thermostat, and maybe some climate scientists could figure out what it is, and then we could turn the thermostat back to where it should be. The thermostat is nowhere. The temperature on the thermostat is 73 Fahrenheit, being turned back to 54 on the image. And that's cooler than the Earth's long-term average. So the giant hand might have overdone it and given us something like an ice-covered planet if you turn it that far back. And then I looked really closely, and in the middle of that image, the thermostat dial is centered on Roswell, New Mexico. And that's not, I don't think it's an accident. I think that the fellow that ran the meeting said, oh, I just took a picture of my hand and I put it up and I made a poster. But there's meaning behind these things that communicates different things to different people. And so, geoengineering ideas. Now, I don't know how much you've heard about this. You've heard that a lot. Geoengineering is a neologism. It did not exist in the Oxford English Dictionary until very recently. If you look into the Urban Dictionary, you'll find it. And it says the last gasp of a dying civilization, geotechnical tinkering, speculation. It's not a thing. It's a set of ideas or suite of possibilities, like space mirrors. I went to a meeting in 2006, and they said, well, let's launch with a railgun. Let's put up a whole bunch of space mirrors. And that's incredible. You'd have this sort of ominous cloud come across the sun. It would be the outer space agency helping to moderate the sunlight. And the intent was to offset greenhouse gas warming by solar radiation management, they call it. Another way would be to put aerosols, which are highly reflective, into the stratosphere by various mechanisms. I'll show you one pretty soon. There's an older one called cloud seeding, which harkens back to the old weather control tropes of the 1940s, where Irving Langmuir wanted to control hurricanes and make the climate change. There's things like growing trees, but here's the iron fertilization. We call that geritol for the oceans. You put that iron in, and actually it was a Colby graduate, John Martin, who came up with this idea at Moss Landing, and he said, kind of in a, I was said that he said it in a Dr. Strangelove accent, give me an iron tanker full of iron filings and I'll give you an ice age. And we can control the planet with iron, which is the limiting nutrient in marine. You guys are marine specialists, aren't you? You know about this stuff, right? Well, you can ask your professors. Then you can pump it into the deep ocean. You can pump it underground. I mean, there's all kind of mechanisms. This family of this thing is called geoengineering. And if you ever go to a geoengineering meeting, the first thing you discuss is, let's get rid of the term geoengineering. Let's just talk about the techniques. And we broke our report into two different sides. One was up here with the sunlight, and one was down there with the capture and sequestration. The current carbon thing, well, that's kind of another thing. And the godfather behind this is actually Edward Teller, the modern incarnation of this. It has a long history. But we went to this NASA Ames meeting about climate engineering. And Teller had passed away, but his chief disciple, Lowell Wood, was there. And Wood is a very aggressive, kind of big bear of a man. He's dropped out of the conversation quite a bit recently, but he co-authored a paper with Teller called The Planet Needs a Sunscreen. And this is sort of like too much radiation, too much warming, we can fix it. It comes out of Lawrence Livermore National Laboratory, where people think they have the answer to big, over-the-top challenges. And so if this engineering ever came about, it might come from a national lab. It might come from the Department of Energy, what may be the old Department of Energy. This was a little bit ominous to me. So I go in there as a former atmospheric scientist, climatologist, a current historian of science. I give a lecture on weather mod, and I hear all these wild ideas, and I said, this is really low-hanging fruit for a science studies person, for somebody that looks at the history and sociology of science. This is just too good. So I took my existing writing on weather control, and I linked it to final chapters on militarizing the planet and terraforming the Earth and climate control. Wood was on the cover of Rolling Stone magazine that month. It was November 2006 when this got started. And he was called Dr. Evil in the magazine. And so that caused a little bit of a kerfluffle, and we had the Rolling Stone magazine there. It was all very sort of serious stuff, but kind of pop culture, because here's one of our protagonists in the meeting on the not in the cover, but inside Rolling Stone. He had a proposal. He called it "Pump It Up, Spew It Out" was the name of his paper. I did some things on that in the book, which you'll have to read, because maybe I shouldn't tell you all that stuff. But there's a high-altitude aero balloon, and it's a military balloon. It flies somewhere at the edge of the troposphere, probably in the stratosphere, and it has a sort of a lift capacity. He wanted to put a long hose up there from the surface, maybe well, you'd need about a 15-kilometer hose to pump up sulfates and have it spew out through some nozzles up there. And he said, it's all physics. We put that stuff up there, we spew it out, and the earth cools up. And so one of my friends was the world's expert in volcanology, and he said, it's not quite that easy. And some of the other people in the group were more trained in weather and things, and they said, well, what about icing on the hose, or what if it decouples, and what if a 15-kilometer long sort of macrophalic hose starts falling out of the sky, spewing sulfates? What are you saying to the world? And the balloon has a ground position error or uncertainty of about 10 kilometers. With the winds changing, you're not quite sure where the balloon's going to be on a given day. So there's a real good chance that you would have decoupling of that hose. And when my friend was talking about how hard it would be to make an actual artificial volcano, Wood stood up in the meeting, full height. He's about 6'6", he's about 300 pounds. And he stood up, he was 2 seats from me. He stood up, and it was a square, open meeting, 20 people. And he said, sit down, shut up, I'm right, you're wrong, it's all physics. And it was that attitude that I know the physics, I'm going to make a gizmo that's going to cool the planet, I know it'll work, you're a volcanologist, what do you know? And that kind of exchange was the most dramatic I'd ever seen in my life. I tried to represent it a bit, that narrative aspect of the confrontation, the passion, the certainty that they were right. And then I found in the New York Times this German cartoonist had captured the moment kind of in a one-panel cartoon. I tend to like one-panel cartoons. The caption here is like 2 overheated polar bears desperately trying to protect their shrinking ice flow by pumping sulfur above their heads, and they're trying to keep this hose up while the nondescript military naval vessels are back here, possibly shooting more sulfates into the stratosphere. Or maybe it's the Russian Navy trying to keep the Arctic open, because there's geopolitics of the Arctic, where we assume everybody wants more ice, but there are people in the world that want to have a Northwest Passage, and they want to have a straight line to China for commerce. And so the one panel thing, I had a lot of fun with this. I hope you're having a little fun. It's lunchtime, and I'm trying to keep it light. But these are Rube Goldberg devices, and I really do believe that many of them are, this is a mousetrap. Mouse hits the canvas, thinks it's a cheese, lands on a hot plate, gets burned and jumps up the stairway, gets punched by the boxing glove, and then lands here and is shot into space by the rocket. This is the kind of Rube Goldberg mechanisms that sometimes I was hearing. Railgun in the Andes, sloped up and shoots space flyer into space. Space flyer dims the sun, making people happy because that stops global warming. It's like the Rube Goldberg chain of events that would have to happen for any of this to work. And again, I could go on and on about every detail of every one of these things, but I think you get the idea that it was not fully thought through with consequences, costs, material. We did a thing on the Crutzen proposal. We calculated how many naval guns it would take, more than exist, how much gun cotton it would take, more than we have in the world, how much tropospheric pollution it would cost to shoot these guns, more than you'd ever want to imagine, just to get the sulfates up there. And then you don't have the permission of the tropical countries where you're opening fire on the stratosphere. So what is a military solution to a problem? It can come down to a simple open fire on it, or shoot it. And so the mindset was very engineering, very physics-based, and very much open fire with military equipment if we're going to stop global warming. I don't think that's the value set that this audience has right now. So Alan Robach, my friend, who was the volcanologist, world experts on volcanoes, he'd studied Pinatubo and the metaphor of cooling off the Earth. Pinatubo cooled us off a couple degrees. But he had a list. He had 19 reasons. He has who has the moral right, who could make a global thermostat, could this reduce incentives to actually mitigate our carbon use, and what would be the side effects. There's a lot you can read faster than I could read them. But I added number 10. I added 10, which would be, would climate engineering alter our basic relationships with nature? Would we think, this isn't the main climate, somebody's pulling levers out there, some government agency has changed it. And there's a good history of that people were concerned about weather modification, whether their weather was natural or was human-made. And if we do this, we start messing with here's one, where was the, oh, there's one here about the blue sky would not exist. It would be more milky white. And I've heard arguments, well, milky white might be a good trade-off for global warming, because who looks at the sky anyway? Or losing track of the Milky Way, not being able to see below fifth magnitude stars might be okay too, because people sit in cities and watch YouTube and stuff, and they don't go out at night and see the sky anyway. You can't see it in Los Angeles. And so there's these aesthetic reasons, and there's a number of concerns about militarization. I'll try to touch on that a little bit later. I want to be careful for time because I know you all have to get on to your next thing. Roebuck had there was a model comparison thing called GeoMIPS, and the GeoMIPS is a set of computer modelers who put experimental amounts of sulfate into their digital models, and they see what might happen. And this is an early run of it where the brown represents drying. It's not all about temperature here. So you put in this much sulfate, you put in the Arctic, you put 3 megatons of sulfate in, and you run the model, and you end up with this whole drying across the lower tier of nations, across the Indian monsoon would be damaged, the Indonesian rainfall in the model would be damaged. And so you end up with a haves cooling the northern hemisphere and a group of have-nots getting their precipitation damaged. And I've actually heard people not trained in ethics but saying that might be another trade-off. And it's a very sad state of affairs with cost-benefit analysis, where the argument is your cost, my benefit, balances out, let's do it. And it's completely wrong to think this way. This is not a completely robust result, but run after run shows a kind of a volcanoes do affect the rainfall in the tropics. So I came out of the meeting, this is all from 2006, the back of the envelope's not good enough. You can't just take out a pencil and make a couple, not even equations, but amounts of sulfate you might need. Simple computer models aren't good enough either, because a lot of the people were not the model makers. And I thought that NASA or the DOE should not be sponsoring this, but it should get out more to the public. So I actually felt motivated that I had a mission to tell the world more about this, not in technical ways, but in ways that might affect them historically, aesthetically, emotionally. And so I wrote the Climate Engineers. This is the URL, and I think you can have access to that free copy. It pretty much says what the book says very quickly. And they got an artist, this is called the Green Goo cover, and they got an angry geoengineer illustrated shooting green goo and fighting against the sunlight. And I came back from the meeting and gave a talk about this. And I'm not much of a cartoonist, but I could do a little Photoshop. And I had this meeting at NASA. Anyway, there's more about it, but I just said, well, if your planet's too warm, why don't you cut off some sunbeams? And this is my take on the Rube Goldberg aspect of geoengineering. I think they were down the fire road the other day trying to keep the lines clear. All right, so have I got your interest yet? Okay. There's more, and I'll go quickly. From the National Academy's reports, 2015, free PDF. You just tell them you're a student or tell them you're going to use it in class, and you download the whole thing. This is the PDF horizon I was talking about. Full color. The mitigation is Plan A. It doesn't. The Royal Society had this thing called Plan B for the climate. It was geoengineering, and that's when we got into this tiff with the House Committee on Science and Technology, and I said there is no Plan B. Plan B is a bucket of proposals. None of them would probably work without vast side effects. So mitigation is still Plan A from the Academy. Adaptation is the second in line. And we were talking this morning about resilience and being able to adjust your lifestyle to the changing climate. But reducing carbon dioxide emissions, capturing and safe storage, I'm not against at all, and then adaptation. But albedo modification at scales sufficient to alter the climate should not be deployed. This was our conclusion. I was the only social scientist really, and there was a whole bunch of climate people on the panel. And actually, the current chair of the National Academy, Marcia McNutt, was a chair of our panel. And we got her to basically admit that this is not engineering, this is intervention. This is not precision, like I was saying about the eyes. I would sign off to get LASIK eye surgery, maybe, but I couldn't sign off for the planet. Maybe it would be pretty tough to get a consensus to do that. And then geoengineering should now be called climate intervention, and solar radiation management, which was a neologism back in '06, was now getting renamed into albedo modification. Management was too, in a way, technical of a term. Geez, I guess I'm going to run through really quickly. I traced some of this in the book back to the early disgracers. This is Helios' son. Anybody study the classics? Phaeton wanted to drive his dad's sun chariot through the heavens, across the ecliptic. And Helios said, well, I don't know if I should agree, but I promised you one wish, and so go ahead. Hold on to the reins, follow the middle path, hold on tightly. Everything went wrong. The horses went wild. This is Zeus shooting Phaeton out of the sky. There's the chariot, and the horses are not having a good time. And if you go back and read about this, Phaeton's blunder, you can get a sense of the human aspiration, but also hubris, to think that they could do something to control the sun. Historically, getting out of the mythology land, but historically, this was our first national meteorologist, James Espy. I wrote a lot about him earlier, and he was the actual founder of the convective theory of storms. So the convective theory says that heated air rises, rising air cools, cooling air will condense any moisture in it, and it'll rain. And that was his theory. It was a very good theory, 1830s. He wrote a book called Philosophy of Storms, in which he said we could make it rain more if we lit giant fires and became more like artificial volcanoes. Humans could become those people who stimulate the convection. So how are we going to do that? Well, we cut down gigantic woodlots along the Appalachian Ridge, and every Sunday afternoon we just torch them. And we make gigantic fires that run from Maine to Georgia, and that'll make gigantic clouds, and that'll make fresh rain to the east. Well, people said, this guy's barking mad. And my friend has developed this meme with Slate magazine. Ray Pierre Humbert was on our committee, and he accused current engineers of being barking mad. I simply accuse dead people who part of the past who were good. But at this point in Espy's career, he was thought to be kind of really out there, really crazy. Eliza Leslie wrote about this in 1842. She wrote about the world of the future in 1942. She wrote about Espy's great-grandnephew as a fictional character who could control the rain, so he could pull the lever in Philadelphia in 1942. And the basic story was, and for interest of time, was anybody who could control the weather would not make anybody else happy. People that thought it was natural now would suspect that somebody else had got their way, that somebody else was controlling the weather. And then, again, because of the constraints, I want you all to go out and put a hold on the library book and read more about it. But this is a picture of our technologies approximately 1945. This is a picture of technologies that empowered people to think they really could control the weather, not just by lighting big woodlots on the Appalachian Trail, or by using specially electrified airplanes like they did in the 1920s, or burning petroleum. There was a big project in World War II to burn petrol to raise the fogs in Britain, like a bathroom hairdryer would clean the fog out of your mirror. They would light gigantic pools of petrol to get the aviators back from Germany. But in 1945, we got this world-changing technology called nuclear weapons. We were testing them in the Pacific and then in Nevada. We also had RCA and some of the early pioneers of computing saying we could make a perfect computer. There was no sense that there was a limit to computational accuracy then. And if we made a perfect computer, you could say, well, we're going to have snow flurries on Saturday, but they're going to start here in Biddeford at 1:43 p.m. and they're going to continue and end at 3:58 p.m. and it's going to be exactly this amount. And so if you wanted to intervene in that snowstorm, you could send a team out to do something. And it was connected with the decommissioning of the military in 1945. And so RCA, perfect computer, send people out, especially in Florida. You could go down and burn petrol across the oceans and maybe steer a hurricane offshore. There's all kinds of proposals from both popular and scientific sources. Irving Langmuir, the Nobel laureate, was cloud seeding. They were seeding hurricanes. They were seeding the desert Southwest. And they were hoping to seed the Pacific to make a very large array that would actually maybe cause something like an El Nino. You could make the Pacific do what you wanted with enough silver iodide chemical. And then we had rockets, and there was a proposal, a serious proposal, to cut a hole in the ozone layer. You know about ozone depletion. Well, they wanted to cut one for the astronomers so they could see through it. They were going to cut it over Chile, over a big observatory. They were going to do it at night, and they were going to make the hole last only for a couple hours so that astronomers could use those wavelengths to see through it. They were going to shoot up a bromine bomb. And then one of the protagonists in the book got worried that maybe the military wants to make a giant bromine bomb. Maybe they would want to destroy the ozone layer over some antagonistic country. Let's see, what would that be? Maybe like the Soviet Union. They have high latitude infrastructure. So there was really a moment here, way before, a decade before the Nobel Prize winning equations of Molina and Rowland and Crutzen on ozone depletion. So there's a standard history of ozone depletion, then there's an engineering history where they knew what they thought they could do with bromine. Then there was the story of nukes in space. If you'd like to hear that, hang around at the reception. And then there was we came to a Tyros moment where when Tyros was launched, one of the chief scientists said, "We aspire to understand everything atmospheric everywhere always." That was the phrase. It was total panoptic understanding of the atmosphere would be given to us by satellites. Total computational knowledge would be given by the computers. Total, input of force. We get nuke hurricanes. We just find the little critters out there in the Caribbean. We get to them with our bombers, and there's a Disney film on this if you want to see it. We can go out and intervene. There's even a Russian film strip from 1960. It says, "What will the world be like in 2017? Why 2017? The centennial of the Russian Revolution. We will be living under the Arctic. We will be controlling tornadoes. We'll be weather heroes. It'll be general weather, not just captain weather. They'll be going out to intervene." And this whole intervention game of the you talk about post-war history, Cold War history, it comes out of these technologies. Now we have nukes, we have better computers, we still have cloud seeding, not federally. We still have rockets, and we have satellites. Even the new GOES is a great satellite. But what we don't have is perfect control, perfect provision. And so I refer to that as the UPC of science: understanding, prediction, and control. Too quickly we jump to control. And right now we're not ready to control the planet. Sorokin did this with his outline of a weather proposal. There's a bunch of scenarios. This comes from Collier's magazine, where there is an attack here across the plains of Eastern Europe. The jets are sent out, but they're not attack jets. They're seeding planes that put in the little time-release balloons. The balloons go off. The pilots are back home safe, but the clouds get seeded by this technique, Collier's magazine, and the clouds grow, and they get angry, and they become cumulonimbus clouds here, eventually off to the east, and the lightning. This is actually your college logo, isn't it, right here? Although it's not a nor'easter. And then if you zoom in on that cloud, you get the cloud hitting the lead tank in the column. So they're taking out the tank with precision. The motif is precision. Langmuir intervened in Hurricane King off the coast of Florida. They went out and the Air Force put dry ice into the hurricane in 1947. And they thought they were going to change its direction out to sea. They were going to make it weaker. But what actually happened was the prevailing conditions brought the storm onshore, and it ended up hitting Savannah, Georgia, and killing some people. So the press the press release, I mean the press conference that was being scheduled right after the run was canceled. And I found this material in an archive that had been declassified only as of 1993. It was just kind of put into a big drawer in Washington and said, wow, that didn't really happen. But Langmuir kept talking about it, and he made the cover of Time for his weather control. This is not the way you want to make the cover of Time. You don't want to be cartooned and buffooned on the weather on the cover of Time. And he was a Nobel laureate in surface chemistry. He made smoke screens for the military in World War II, and he made this weather control technology kind of possible in the 1950s. And then he was deemed barking mad. So the warning to current engineers. I gave this talk once, or a similar talk to the people who were engineers, and I never attacked them personally. I just said historians are going to take a close look at your work in the future. Okay, and then should I do this? I just skip over this part, right? No? Okay. Donald, this is Disney, 1953. Again, the cartoonists jump in there. They make up the storyline where Donald Duck is a rainmaker. He's got a bag of rain seed, and the farmer wants to have 2 inches of rain on his barley field. And Donald gives him a good deal. So he goes up and cuts some beautiful clouds. This is a cartoon panels of precision. Donald shapes the clouds perfectly. He lets the rain fall only on the barley field. Even the half raindrop doesn't go on the other farmer's land. So it's a trope about precision where he gets 2 inches to the millimeter. If you're into scientific measurements, you know what that means. So he's very happy with the commercial. This is commercial rainmaking. There's a commercial side to this technology. Then there's Donald always gets mad. He always blows his top. That's just what Donald does. And Daisy's out philandering with another duck, and they're having a picnic, and Donald's cut out of the scene. So he goes out and he gets mad, and he takes his rain seed up there to make a militarization of the clouds. He gives them a blizzard. He blows away their picnic. He overseeds the clouds through the canyon. He's roaring up there, really, really mad. It says rain, hail, snow, blizzard, and there's Donald. And he overseeds the clouds and makes a big ice storm over the canyon, which then falls down, crushes the cars. It doesn't hurt anybody because it's Disney. And it crashes into the cars. And then they're trying to figure out who did that. Who did that? How did that duck know the clouds were made out of ice? And Donald's sneaking away in denial. And one of the tropes of weather control is that you could deny it. If those clouds went across Eastern Europe and caused mud to fall and the lightning struck the Soviet tank, you would say, oh, that's too bad, you had bad weather. Not that we caused it. You have to preserve deniability. So Uncle Donald goes off to Timbuktu. Is that what it is? Yeah, Timbuktu. I think there's a branch campus of UNE that's opening up soon right there. But the story, if you read the whole panel, it's Donald Duck, Master Rainmaker from 1953. And I didn't bring the Disney movie, but here's the Russians we're talking about making. This is a blossoming tulip over the Arctic Circle, an open Arctic, cities blossoming around the Arctic Rim, and a gigantic, this is a rocket taking particles up to make a Saturn's ring around the Earth. So there was not a serious proposal, but there was a book about making a ring around the planet, and if you tipped it just right, it would illuminate the ice over the Arctic and it would melt it out. About 1960. Again, this kind of Russian fantasy is covered in the book. There's the 2017 film strip, the year 2017. In the year 2017, when we celebrate the grand anniversary of the revolution, we will live under the Arctic in cities that are buried under the ice, but it'll be very nice because of the superpower we can use down under there. We'll also make special weather control flying machines that can go out and take out a hurricane. In this case, in the story, they take out a bunch of nasty tornadoes over the Black Sea. And then so there's a heroic storyline. I'm going to kind of wrap it up here pretty soon because there was actual, I've been talking about proposals the whole time. I'm talking about Espy proposing to burn the Appalachians and Teller proposing to have a sunscreen for the planet. And this is actually what happened. 1958, James Van Allen discovered the magnetosphere. So the first U.S. satellite discovered something brand new about the planet. The third one too, it sort of reinforced the idea that we have a magnetic sphere circling the planet. We didn't know that. And the same day they announced it to the National Academy, Van Allen agreed to blow it up with the military, a test in the magnetosphere. And so this is Ernie Ray, one of his associates, on the blackboard at Iowa University. 1958 Gamma, that's the third, Alpha Beta Gamma, that's the third satellite. The second one blew up. Space is radioactive. Now, you know from Captain Kirk that space is the final frontier, and you know that space is a vast vacuum. But space is radioactive. That got the military really interested, because these were radioactive particles circling in the magnetosphere, or they were electrons. So we could add more electrons to it with a nuclear test. So they tried it, and they went up. Oh, sorry, this guy's already barking mad. Gave away my punchline. But Nicholas Christophilus, who's my version of Edward Teller Light or Dr. Strangelove from Berkeley, was giving a talk out there about weaponizing the magnetosphere. And he has actually, the project was called Argus. 3 A-bombs shot over the South Atlantic into the very high altitude to see what would happen. Now, that's very Baconian. If you study Francis Bacon, you've got to torture nature to have her reveal her secrets. And one way to torture it was to go ahead and discover something and then try to blow it up. So one of the standard experimental methods of science is to cut things apart or blow things up or crash particles together and see what the debris is. And so Christophilus is giving a lecture about the Earth and its magnetic bands. And what he's saying here, and I have the transcript that goes with this picture, if you set off a high-altitude nuclear test in, say, the South Atlantic, the lines of magnetic force would be such that it would cause a hell of an EMP over Moscow. So they could weaponize this notion of the magnetosphere. They could either set off the bombs above our own cities so that the Russian bombers couldn't get through the debris, or they could knock out the Russian bombers with bombs, or they could make an EMP, or they could knock out radio communication with a big bomb, which is exactly what they did in 1962 with a project called Starfish Prime. This is over the Pacific. They shot Starfish Prime, they announced it ahead of time. They shot this bomb off way above the Pacific Ocean between Johnston Island and Hawaii, and it wiped out the radio traffic across the Pacific for 48 hours. Nobody could reach New Zealand, nobody could reach Australia, and so there was just a shh across the Pacific. And the first message through to Johnston Island, they thought they had killed themselves. They said, the Pentagon got a message to Johnston Island, "Are you still there?" And then they got a little response back. And people in Hawaii went up on the hillsides, and they actually scheduled what they called rainbow bomb parties. Is anybody here in like American studies or in cultural studies? Or they actually served specially mixed drinks with little rainbow nukes on for the swizzle sticks. They would sit out on the port. Maybe this has to do with tourist history, if they had special cruise ships. But the AEC, the Atomic Energy Commission, announced the test. People went out to watch the test. And then the EMP from that bomb knocked out their garage door openers and their traffic lights in Honolulu. These are heavy switching materials that were knocked out by EMP from that test. And also they called the light show the Aurora Tropicalis. It was a human-made aurora. Now that is geoengineering. It's not geoengineering for climate, it's geoengineering for military purposes, to tinker with the magnetosphere. Van Allen actually said, later in life, he said, "I wish we hadn't had blown that H-bomb up in the magnetosphere because it ruined the natural magnetosphere for 10 years. There was no more measurements that could be taken that were background measurements after that bomb." And that was 62. It was only 4 years after the discovery. There we go. Now you know why I put that on there. And so there's Starfish Prime, the Aurora Tropicalis. I have a paper on that. I'll send it to you if you write to me. And so I went to another meeting recently. They were trying to make a policy regime for geoengineering. And they were saying from the front podium, "We don't have a history of geoengineering." And I said, "Yes, we do." And I was kind of being like telling them some things they maybe knew but didn't want to hear. Things are moving so quickly, we don't have the luxury of looking at history. They have this urgency thing. We gotta make these geoengineering techniques so they work, so we can save the planet. take the time. I suggested between 40 minutes for the article and 3 or 4 hours for the book, or maybe a little bit longer if you want to enjoy it more. But you don't have to become a historian. You just have to be open to the notion that this stuff has been thought about, proposed, and even tried in the past. And we don't want to get into that, repeating the history that we already know. And we are the first generation to think about this. This was back in the 2006, it was 2010, and the big word was unprecedented. Everything's unprecedented. And that's where I came up with my personal motto that everything's unprecedented if you don't study history. And so history says it's not unprecedented. There are people that thought about tinkering with the planet, and the Research Council did that too. There's the reference to the 2015. So I'm going to wind it up here. Thank you for your attention, because the Earth is at a tipping point, but Archimedes is not the model for that, because if Archimedes has a place to stand and a lever long enough to move the Earth, I heard an engineer once talk about this being technology and this being sort of like space capacities to move the Earth. The tipping point is a metaphor for climate too. We're at the tipping point. And I just ask, where would it roll if you tip it? So that's my story. I'm sticking to it. And I thank you for your attention. And it's before 1 o'clock.
I think if people have questions, go ahead and do that.
Questions, comments?
We're saving them for
Announcements?
No, you don't have to.
You don't have to?
No, I get it.
Okay.
When we talk about fluoridation, reducing that fluoridation,
Louder, please.
we also think that sunlight is the basis for photosynthesis.
This doesn't work.
I don't know if Ada, do you use something for that?
I gotta give her that one. They want to hear you on that side.
Besides giving us heat, the sun also is the basis for photosynthesis on the planet, the basis for all of our food chains. I've never heard anyone who talks about blocking the sun address the question of whether it reduced the total amount of photosynthesis on the world and capacity of our humans.
Okay, good question. So you heard the question about photosynthesis. There are papers, there are advocates that a multiple scattered light is good for plants, and that plants get their photosynthesis not only from direct solar but from scattered solar. So there are some studies about, and there's studies about engineering. Genetic engineering is actually linked to climate change in some narratives. And one would be Bill McKibben's early book, Death of Nature, does that kind of thing. But there was a semi-serious argument that this could be good for agriculture if we make the sky milky white instead of a shining spot and nice and blue. And there's another argument against it that says, well, if you make a big solar array, you're going to reduce the efficiency of these solar collectors that are engineered to run on direct solar, because you'll have more scattered solar. So they're back and forth, but the plants are in the mix now, and there's the genetic engineering was aimed at making crops brighter, sort of like the cover the earth with white paint, like the Sherwin-Williams thing. But instead of paint, you use a brighter crop. Maybe you make soybeans that are genetically modified to have brighter leaves and give you a better reflectivity. So there is literature. I've never heard anybody talk seriously about it, but I do know there is some stuff on that. And there's a great big, if you want to go to Berlin, there's a great big geoengineering conference in October. And so the Journal of Tourism History is going to sponsor a trip to Berlin for the geoengineers. It's a wild meeting. Over here. No.
So, sort of related to what Bethany just asked, at these geoengineering meetings, are there any ecologists that attend these sessions? Because it seems to me that the engineers and the ecologists don't seem to be talking to each other. There's a lot of complexity in ecology, and I think even biologists sort of poo-poo ecology as, okay, well, we might get to that by the end of the semester if we have time, but that's the simple stuff. Where I think in reality it's probably as complicated or more complicated than any of the rest of biology. And so I'm wondering, are those conversations part of this?
Is your background ecology?
Yes.
I just wonder if you're coming to Berlin with us.
Oh, I'd love to.
No, there's not a very robust spread of disciplines, but like I said, there's literature on this. I haven't been to enough meetings to know, but the origins of chaos theory comes out of tipping points in ecological systems too. I don't know the history as well as I should, but there's this introduced species idea: what could possibly go wrong? Well, the rats could kill all the birds, the snakes could kill the birds, and this, especially on island communities, that kind of literature. And so I think that my friend Alan Robach was playing that role as an atmospheric scientist, saying that an artificial volcano, Pinatubo, actually changed the rainfall across the planet. And Pinatubo actually damaged the ozone layer as well as cooling the planet. And there are proposals, so I deal mostly on the physical atmospheric science side of things, but there are proposals like, let's get rid of cirrus clouds, because cirrus clouds help heat the climate. Or so there's this like ban cirrus clouds. You get like little cirrus clouds with an X on it. And I said, well, what else do cirrus clouds do? They play other functions, including aesthetic functions in the sky. But they also play a role in the rain cycle of making clouds build up. So certainly this kind of discourse has to get much broader. A good critique can come from ecology, that's for sure. Yes? Student question. Oh, Bill, go ahead. I don't mean to control them. I don't see them.
I guess we're all students.
We're all students.
So if there's no way to geoengineer and repair something, and we have to reduce emissions, what is your take on what I see as mainly economic disincentives to build the solar? We are so wedded to oil for correctable reasons, economic reasons. What do you think about that?
Right. I agree. I think we have an engineering future, small e, lots of different ideas, how to make a good solar collector, how to make a clean carburetor, how to reduce dependence on oil. But I don't think we have a geoengineering robust future with a big E, with a big GE. It's this image on the cover of the book about the technocrat pulling the lever, controlling, this is from 1954, the technocrat pulling the lever and making things happen and automatically changing things with a big leverage point. That's the kind of engineering I would push back against and say, have you thought about the social and ecological consequences? But the small engineering, I think we are going to end up, we're going to end up with a more managed planet. We're going to end up with more engineering in our planet, more Internet of Things, if we can protect it from hacking, And that small e, I'm certainly in favor of clean air, quieter cities, cooling off the climate to the best of our ability, minimizing human influence. So the two narratives are not opposed to each other.
Is it oversimplifying to say that hasn't happened much yet because of non-scientific reasons, because of economic reasons, subsidizing oil companies and all of that, keeping us, most of us got here in our cars. I guess what I'm saying
I
is...
fill up once a month. I got a hybrid, and whether I need it or not, I
But you still fill up.
I do.
And you still drive a non-solar
And I will drive at
powered-
60 miles an hour in an electric car if they make one that doesn't burn up.
I know. I guess what I'm saying is, in my amateurish view of this, it seems like the biggest hurdle is we don't want to switch over. We don't want to create the economic incentives to fully develop solar power.
Right. I think correct me if I'm wrong, but I think we are switching over. It's just not that kind of throwing the switch. And so I'm concerned about the hubris and the arrogant actor trying to do something and not knowing the consequences, the low wood kind of approach. And I'm not as concerned. I'm concerned about the pace of the other things.
So you're optimistic.
I am optimistic, and so gloom and doom, you want another lecture about how to respond to the Anthropocene, we can hang around, but gloom and doom are not going to do it, and denial's not going to do it, and cultural suicide's not going to do it, and hedonism's not going to do it. But how would you respond if you think the world's coming to an end by 2050 or 2100? we were having it was a bunch of geoengineers. It's like sounds like a joke, a bunch of engineers sitting around having dinner. This actually happened, and they're pretty highfalutin engineers. And we were having some wine and dinner, and they were talking about, I think the world's going to end in 2050, and the others said, no, I think it's going to be 2100. And I said, excuse me, but what would you do between now and then if you think the end of the world's coming? And the response I got was, oh, Jim, that's the wine talking. but you got to take it seriously. What's a 22-year-old going to do if you think the world's going to end? I mean, if the gloom and doom narrative becomes your primary consciousness, if it's 57 varieties of pollution, if I write a new book called Fixing Everything rather than Fixing the Sky, if everything's going to hell, what do you do in the next 25 to 50 years? You could become culturally suicidal, or you could become a think tank. You could become a community of solutions, community of people that both personally and through your alliances and your activities, whatever else you do, you make it so things turn out better. And then if we go to hell, then it's not your fault. No, but there's a serious psychological aspect to climate change. If you buy the narrative and get frozen into inaction, that's one of the worst things that could happen too.
You keep talking about all the things we can put in the atmosphere to fix the problem. What about are there efforts maybe to just get the carbon out of the atmosphere to remove things? Or what kind of efforts are being made there?
The second volume of that report was focused on carbon capture and safe, reliable storage. And my colleague Jennifer Wilcox has written a book called Carbon Capture. An interesting thing to read. But I asked her, I said, what about long-term storage? And so our committee ran up against the barrier where if you capture on a planetary scale all the emissions of carbon dioxide in the world, and it's like more than 3 times more than the carbon we've used because it's oxidized. And how do you purify it, pump it, put it underground, put it in the oceans, put it somewhere? How do you keep it there for more than a millennium? We don't have any institutions that have ever done that. The Catholic Church is an old institution, but they were never into carbon storage. So there's an article, there's a special issue of a journal by a guy named Toth, T-H-O-T-H. He wrote about the comparison between carbon storage and nuclear waste disposal. And he actually said that nuclear waste disposal might be a bit easier because at least it decays and it's not the same volume as all the carbon. So the experimental stages now, there's people making artificial trees, there's people making carbon scrubbers, there's people looking into the ocean iron fertilization mechanisms. There are approaches, but they're all very, very, very minuscule, and they're not at the scale that we would need to decarbonize the world system. There's metaphors. We kind of desulfurized the world. We were able to reduce a lot of high sulfur fuel, and we were able to take out certain elements from our fuel supply, like lead. But this is a much bigger thing with many more sources. We were able to take out CFCs by a treaty. But it's a much bigger thing to talk about carbon, which is the plant food of life as well as the global pollutant. And if you just, my proposal was to put little markers on just the fossil carbon and make just fossil CO2 a special chemical marker, tongue-in-cheek. And then put little nano springs on the molecules so they don't rotate or vibrate anymore, and then they would be radiatively neutral. That is a complete farce. But you can get in certain circles and talk like that, and people say, "Yeah, nanotechnology that might save us." But the serious answer is, it's a very, very large scale capture problem. It's a very large scale thermodynamic issue, a very large-scale economic issue, and it's a very large-scale storage and safe maintenance issue. So the cascade of those gigantic issues means that we have a long, long way to go. And if you go too quickly, the groups that are scaled up to maybe pump and store things turn out to be the major oil companies probably. That can make that much piping. You end up with with the Dakota Access Pipeline, this is going to be much bigger because there are going to be pipelines to put it into storage facilities. So you end up with the social consequences being very big too. So that's a place where I'm not so sanguine.
I've read a lot about what chemtrails are. Yeah. So I was wondering if you can explain what they are and what your take is on them and how they affect the atmosphere, if they're real or not. But I know a lot of people that I know that don't believe in them. So can you talk about that?
For me, chemtrails are cirrus clouds, and they're water vapor emissions that come out of burning jet fuel. And in certain circumstances, the contrails actually disappear pretty quickly because it's dry up there. At other times, when it's more moist, they kind of spread and they make it sort of cirrostratus haze. And chemtrails are mythical creatures that refer to a conspiracy theory that the government's trying to poison us, or that the military's already trying to cool the planet with secret projects. This goes on really big in California. We had a geoengineering meeting at the AAAS San Diego, and outside the building were the chemtrails protesters. Inside our building, we had the panel on climate engineering, and the AAAS was really worried because they had the first time they'd had a protest at their meeting. And I remember saying, I don't know who's battier, the people in the room or the people outside, but there was no belief or evidence. I work with archival materials, and I work with, I don't have a military clearance, but I work with old military stories about the interventions and stuff. And I don't have any documentation of chemtrails at all. But I do have people who are very sincere. They feel ill when they see cirrus haze or cirrostratus clouds, and they feel that the military must be doing something to test it. But for me, it's not part of history. It doesn't prove it doesn't exist, but it's not part of history. They're serious ones. So, last call, huh? And we're going to meet here too again later. So
Thanks for coming. General Accountability Office, served on panels. This is a fairly substantial CV here, I think you'll agree, and served on panels at the National Academies of Sciences. We had a wonderful discussion earlier today with an environmental sociology class that was wide-ranging and covered not only history, but a lot of Jim's other expertise as well in terms of policy and advocacy. So he's interested and able to speak on that as well. Please join me in welcoming James Fleming.
thank you very much. I'm so happy to be here. I'm happy to be on this side of the Saco River because I went down the wrong side this morning and it was a little bit late. But no, Eric's been a great host and looking forward to the day here. It is lunchtime, so I'll try to keep this a little bit more entertaining than not, I hope. And none of it will be on the final exam, I don't think. Yeah, so I'm here because of an airplane crash, and used to be a research meteorologist. Used to fly in clouds. I used to write little computer code to model clouds, and then we almost clipped off some, or we almost crashed. We clipped off some pine trees landing at a regional airport, and I was in charge of the particle collector which collected the pine tree. We didn't crash, but we almost did, and I said, gee, I need a new mode of engagement with the atmosphere, and I think that'll be history. So this is a history of intervention. I just got off of a National Academy panel called Climate Intervention. You can get the free PDF from the National Academy, 2 volumes. One is on modifying the albedo or changing the insulation coming into the Earth. And the second volume is on carbon capture and safe storage, not just capturing it. And I'll wave 2 books. This book was 2010. If it's not in your college library, it'll be there by the end of the day. It's called Fixing the Sky, The Checkered History of Weather and Climate Control. And that's based on this. And I'll get to the Academy report near the end when I start to talk a little bit more about policy. And then, as Eric said, I just finished Inventing Atmospheric Science, which is from 1900 to 1960. And I dropped the story off just when Ed Lorenz develops the chaos theory, and we finally have a weather satellite flying. And it kind of goes from Marconi to weather satellites, and from early attempts to make a meteorological time machine to look into the future, to the point where we said, wow, there is really a limit to our provision and how far we can see into the future. So again, if it's not in your college library, it will be, as thank you for inviting me here. Fixing the sky. When I moved to Maine, it was this was the New York Times that day. It was 1988, and I got a copy of it, and we had the rental truck, and we're moving up from Washington. And I remember quipping to my spouse, I said, looks like we're headed in the right direction, because Jim Hansen just said global warming has begun. And that's the beginning, 1988, of a vast expansion of the literature, from journalists, from scientists, from pundits, from sociologists, from economists. And so the literature just exploded. Hansen has nuanced the
one, and I'll introduce our speaker in just a moment. At 4 o'clock in this room, free food. We'll just sort of mill around and chat. We've got the good food, the bacon-wrapped scallops, the single best thing that Sodexo does. And that's what we're, I mean, they are, beautiful thing, beautiful thing. And then at 5:30 in Alphon 205, our second speaker of the day, Cameron Wake, will be talking about the science and the politics of climate change and things that we might be able to do here in New England. And his focus is really on New England. All right, but our first speaker, and I learned this on Twitter yesterday. His nickname is Captain Weather, so that's a pretty good nickname. We'll have Dr. Climate and Captain Weather today. So it's like a superhero matchup, which is pretty great. James Fleming is Charles A. Dana Professor of Science, Technology, and Society at Colby College. He has been a research associate at the Smithsonian Institute, holds degrees in astronomy, atmospheric science, and history. His books include the Meteorology in America, 1800 to 1870, from Johns Hopkins Press, Historical Perspectives on Climate Change from Oxford University Press, The Calendar Effect from AMS, Fixing the Sky, which will be the topic of his discussion today, from Columbia, and Inventing Atmospheric Science, published by MIT just last year. He's been a fellow at the American Association for the Advancement of Science, the American Meteorological Society. He's testified before Congress, consulted with the
statement since, but this was the cover of the New York Times on the greenhouse effect, about July 1st, 1988. My assumption is to get involved in climate intervention in a heavy-handed way, or to think about fixing the Earth through an engineering scheme. You really have to be motivated, and one of the motivations is fear that the treaties aren't going to work, that individual virtue and mitigation and changing light bulbs is not going to work. And so that a lot of engineer types have thought about, let's make an artificial volcano, or let's make the oceans absorb more carbon, or let's put a whole bunch of water pumps on the polar ice cap, maybe 1 million of them, and have them make more polar ice. And so engineering projects are rising, especially since 2006. When Paul Crutzen wrote his editorial about a policy contribution to climate change. His contribution was, let's use naval guns and shoot sulfates into the stratosphere in the tropics. And so if you think that's a good idea, just hang in there, like buckle your seatbelt. Then we have my friend Bridget Schneider, works in Potsdam with the IPCC. She works on the color diagrams, and what happened was the Intergovernmental Panel on Climate Change always published their reports with Cambridge University Press, and they came out a year later, and they were great big thick things with color separation. And then our world passed what I call the PDF horizon. It was somewhere about 1992, 93, but more and more.
Thank you very much for coming. My name is Eric Zelo. I'm the chair of the Department of History and Philosophy. and also the chair of the committee that is organizing the Connections lecture series, of which this is the first event. A few years ago, we had a series called Core Connections, and in many ways, this is a kind of revival of that, but with a slightly different mission. So the Connections lecture series, which I hope will continue for many moons to come, works at showcasing interdisciplinary scholarship and interdisciplinary ways of thinking about challenges in the natural world and in the course of human affairs. Generally speaking, the world does not work in easy disciplinary boundaries. The questions that we need to ask, the problems that we face, involve a lot of interconnections and a lot of challenges that require different approaches. And so this is really a series about that. And I think climate change is one of those topics that definitely winds up crossing a lot of boundaries very quickly. There's a lot of natural sciences there. There's a lot of questions in terms of social sciences and politics and sociology and anthropology. There's a lot of questions in terms of the way that the humanities look at things as well. And so the committee decided, as we were thinking about what we wanted to do for our first series of events, to look at climate change from a variety of vantage points. And so we have 3 different things happening today that I hope that you'll take part in. Obviously, you're here for the first